Okay, gentlemen, please take a seat. And unfortunately, I was not wearing my headset, but I learned from the technicians that you have to speak directly into the microphone. There are microphones where you really need to use them very closely to your lips, otherwise people cannot hear you. In the afternoon, we had a question on the next steps after the ultrafan. Is there a favorite technology? And Dr. Kaiser, you said we have the engine where you are experimenting with water. Is that the next step after the ultrafan? So does my microphone work? It works. So this is one option. And all manufacturers are working on this kind of technology with no exception. Everybody tries to be more efficient, tries to develop a new engine which brings us a fuel consumption reduction of 10%. So this is the holy grail, so to speak, a 10% reduction. And people always try to come up with new ideas. However, there's also one disadvantage. Think of the engine fan. We have additional weight, and it took us quite long to get it improved, to prove that it's reliable. So something like a wet engine is getting even more complex, which means we have to take many more efforts. So we can see a propulsion system has to be closely integrated into the entire airplane structure. There are 3 points. Think of the fuel lines, for example. They're getting more and more difficult in these kind of concepts. The first drafts of the wet concept led to lines ending up in the fuselage, and then we had the condensation there. But this is a no-go for many plane manufacturers, as other options cannot be used anymore. Did you have already some contacts with the wet concept? Mr. Stoker, you're using the microphone. You have it ready?
You know, I would say...
Ganz nah an den Mund.
Even closer, okay. I don't know what the next generation engine technology is going to be, and I don't know that we want to, I from a Boeing standpoint, want to pick a winner yet and say now this is what it is. I think it's still a little bit open to try and figure out what it is, and then one of the key things that we keep talking about is a lot of times the engine manufacturers, no offense, will go out and say, hey, this engine is 10, 20, 30% better than our existing engine. But we have to integrate that with the airplane, and sometimes when you integrate it with the airplane, the efficiencies aren't there. It might be 10 or 20% better on SFC or something like that, but maybe it prevents you from doing laminar flow in certain areas, and so you don't get quite all the same benefits, or it weighs more, and so you don't get the benefits, and things like that. And so, you know, I think what we really want to do is work closely with the engine manufacturers to make sure that integrated, we end up with a better overall airplane that's got the engine airframe integration that it needs to be to go to the future.
Vielen Dank.
Thank you very much.
Agree on this point, and I think I already said it during the presentation. The work with engine manufacturer is getting really a huge part of the game, because when we are talking about decarbonization, for sure the engine is playing a huge role in these parts. It has to burn different type of fuels. It has to be different, like the wet concept, on which I've not worked too much, sorry, so I wouldn't dare express my views on this one, if it's good or not good for noise. But indeed, working together, that's really the main stake. That's something we have to, I wouldn't say learn how to do, because we are already working together, but take a new step in this direction.
Vielen Dank.
Okay, let me ask the expert. You introduced the ultrafan to us. What about the wet concept? Are you still thinking, are you already thinking beyond the ultrafan? The ultrafan is the next generation, and I don't believe that we should skip skip one generation. I think there is optimization potential we should fully seize with the existing engines, and we need to make sure that everything is properly integrated in the airframe. Only then we can seize the full potential, and only then we should move on and develop completely new technology with new risks involved. And then we will see what the winning concept will be. At the moment, it's difficult to say. I think all kind of components need to be improved, and then we have to bring them together into one common concept. Thank you very much. We heard a lot about electric propulsion, and you said the batteries cannot be that strong to flow longer distances. Maybe they're only for short-haul flights. But what about hydrogen together with fuel cells? What is your personal assessment on hydrogen as a fuel for the future? Are there any ideas? Is there any research being done?
Research being done, yes, quite a lot. I'm a noise specialist, so I couldn't tell you how much quantity you need and how much weight it adds and so on. I would need the help of my future project colleagues, which know that much better. But what I can tell you is that yes, we have three ideas of how it could look like. We didn't have found any showstopper at the moment. There is no blocking point to go in that direction. We're not sure yet it will be an efficient aircraft, and we have still a lot of work to be done before releasing anything, but the work is going on. Yes, we are still believing in it a lot. For sure, it's not only to have this kind of aircraft flying, it's not only about having the aircraft, but having the fuel for that. So hydrogen available, which is another part of the story. But yes, at the aircraft level, yes, we are still working on it and still believing it's a good candidate for the future.
Vielen Dank.
Thank you very much.
To study all kinds of things. I don't know that hydrogen is going to be the next thing that we look at, or in a serious way. We're going to continue to look at things like fuel cells and electric, and understand how that fits into the overall market. Obviously, there's some things with battery technologies that we'd like to see get more efficient and get the weight down. But as Stefan said, it's that integrated problem when you get into hydrogen. Where does the hydrogen come from? Is that a carbon neutral situation, right? And you've got to kind of solve some of those problems. And so, we're probably going to concentrate more on how do we get sustainable aviation fuels in and look at how that works. And then I think hydrogen is going to be a farther showstopper out there. Maybe not a showstopper, but a farther reach for us before we really get into that.
Vielleicht kann man das nochmal sagen, dass aus Umweltgesichtspunkten, also aus Emissionen.
Well, from the emission point of view, a few words about emissions. I think in this respect, two strategies could be used. First of all, people could try to use synthetic fuels, and in the long run, hydrogen might be the plan B. However, this is something which belongs to the future, and until we have a reliable fuel, it will take quite a while. But from the noise point of view, there's not much of a difference. And what about the alternative fuels? If I got you correctly, the new planes are using alternative fuels? Yes, more or less, but getting these alternative fuels might be sometimes problematic. But this brings me back to what Dr. Richter said. He said in the lifetime of a plane, there is some saving potential as far as fuel is concerned, but not when it comes to noise. Yes, this holds true for alternative fuels and for hydrogen. We have proven already that they're capable of flying with 100% alternative fuels. And as far as hydrogen is concerned, we are doing research on the direct combustion of hydrogen, and we're also analyzing the fuel cell usage. We've seen pictures of open rotor and open fan solutions, and then you might be shocked at the beginning because you think it will get much louder, but you said there are improvements possible. And now if somebody asks, somebody who's really critical, what about the open rotor system? Can that higher noise level be compensated with doing something on the blades? A classical propeller can be quite quiet, but it depends on the speed I'm flying with, on the performance, and how efficient is the entire system. But you cannot fly that fast. There are propeller systems like the Mach 0508 is possible, an 8400 is very good already, but when it comes to the open rotor, we already had some test flights at the end of the 80s and 90s, but they were quite loud, if you recall that. So there is some potential. However, how much money can we spend? If you think of the classical gas turbine, a lot of technology was used, a lot of money was invested, and it might have a certain benefit if I have the nacelle around it, not only from the noise point of view, but also when it comes to efficiency. But it's true, from a specific bypass ratio onwards, it is becoming less efficient if I have the nacelle around it. This is what all tests have shown. Only a certain degree can be reached. Maybe the next or the second to next generation can reach that level, and then we have to check out the open rotor once again. So this is why tests are so important, to figure out where the problems are. Otherwise you have technology ideas, but you do not know the minor hiccups, which might be the difficulties in the implementation later on. And this brings me back to what you said. Very early on, you have to focus on noise. In the past, Rolls-Royce already had open rotor systems in our research activities, and we could see a dramatic CO2 reduction. And if I think of Mr. Stoker's presentation and what he said, then we know that this differs from conventional engines. This kind of tonal noise might lead to a different perception. And apart from that, we have the RISE concept, which was also mentioned, which was not analyzed by us, but by our competitors. And this is what the competitors have on their list. What is the RISE concept? The RISE concept, I don't know everything about it, but the colleagues might probably know more about it. Can you tell us something about the RISE concept?
RISE concept, I can't even remember what the acronym means. Revolutionary? No.
I don't remember either.
So we should invite CFM next time.
Okay.
It's a concept which is coming from the years of the contra-rotative open rotor engine that was tested in the 80s and dramatically noisy. Studied a lot in Clean Sky 1 and 2. We did a good progress on these two propellers rotating one in front of the others. But still, in terms of noise, it was quite a challenge, because the fact that you have two rotating propellers, it was good for efficiency, but it was making a hell of noise because of the interaction, and a very strange, as you said, Rob, very strange characteristics of sound, sounding really, really annoying. And finally, at the last stages of Clean Sky 2, they come up with this idea, why not stopping the second rotor to rotate? And it becomes a kind of OGV with a variable pitch, like the OGV you could find on the turbofan today. So only the front part is rotating, the second one is fixed with variable pitch. The front is with variable pitch also. And well, at the beginning we were saying, okay, well, we are coming back to a classical propeller, but finally not. We still found part of the benefits of the contra-rotative open rotor, but without the penalty for noise of the interaction, which is far less, and also the weight has reduced a lot, because it's not that complex mechanism with two shafts which are addressing the two rotating propeller. So yes, they finally came up, well, they went back, CFM went back and worked on the topic, and they came back a few months ago with this proposal that we will evaluate, indeed. There is some potential there, but yeah, before it has been on our FTB, I will wait to say whether we have a good candidate there.
Yeah, I'll just add some things, because I think it's really difficult to test some of these concepts for noise in a way that goes all the way to full scale. You almost have to do it full scale to get the right Reynolds numbers and the right tip Mach numbers and everything that you want to get right for understanding what's going to be in flight. And so I agree. I think it looks a lot more positive than a number of the things that we've looked at in the past that were extremely noisy. Just exactly how good, I think the uncertainty is pretty high, and through some of the testing that's going to happen, I know you guys have a test on your A380, we're going to look at some stuff on a 747. You know, there's other testing that'll come up that'll give us a better idea of exactly where that is from a noise standpoint.
Okay, vielen Dank.
Thank you so much. So if I got you correctly, you're saying noise is always an important factor, even if it is not your primary reason to develop something, but it is part of the efforts you're taking to further develop something, to newly design something.
Punkt, der im
Dr. Kaiser mentioned a point that is omitted, that was the supersonic aircrafts. And I talked to others, they said, no, this is not the case. How can we estimate that? Maybe one point we should say here, there are recent research projects that deal more intensively with that. There's the BOOM project of NASA in the United States, where the supersonic bang is to be reduced. But there seems to be little application in civil aviation. There are companies that deal with that, yes, but it doesn't seem to become marketable. Would the other three agree to that?
I'd say that, you know, we continue to study almost everything. Like we will do some studies on supersonics to try and understand the market and where that is. But I do think, you know, from a noise and emission standpoint, it's a very hard thing to get together and understand what that supersonic airplane would really do and how it would compare to a subsonic airplane in transporting that number of people or that much cargo. So I think it's a tough sell to get the supersonics right now.
Yeah, on the other side, you have seen nothing about supersonic. Yes, we are not actually working on supersonic at the moment. We have still so much to do. We want to add this one, but clearly what is currently being discussed in terms of regulation at ICAO level is to have a robust and I would say a fair regulation for supersonic aircraft, incorporating both the landing and takeoff noise and the boom. And all that is worked at the ICAO level, and I think there's quite a good work there to be sure that if a supersonic aircraft comes through and comes to life, its annoyance will be manageable and not like the Concorde was typically.
Rolls-Royce is an dem
Rolls-Royce participates in the Seneca project of the European Union, and it looks into the analysis of supersonic regulations and also alarm and emission, noise and emissions. That is a very good consortium that has come together for independent European opinions to be developed. And from the noise point of view, I can tell you it is indeed possible to design supersonic aircrafts that fulfill the recent noise regulation. According to the recent regulations, they could be approved and registered. What you have to do, however, is you have to allow for variable noise reduction systems, as they are mentioned in the regulations, that consider the special features of the engines. Otherwise, that would lead to a situation that you start much too loud. But with that change, which automatically would happen with every start, you can reach these so-called LUM values and also use a supersonic aircraft. Thank you. As to aircraft design, we also have a question here. If obstacles on noise optimization are for aircrafts, maybe ICANA should really give an incentive for approaches. If obstacles for noise optimization of different plane profiles, then should ICAO not be an optimum for, should be an incentive for optimal designs? I don't really understand it either. Maybe it's the approach processes. Sometimes they are not adjusted properly to the aircrafts. And I remember a study from the United Kingdom in which it was found that especially the good slope gliders that are climate friendly not necessarily are in a condition to do the continuous descent approach in the best possible way with the angles and speeds required. It would make sense to consider the capabilities of aircrafts in that respect for the operational procedures for this descent method. Yeah, that was mentioned before, that every aircraft has a different optimum. Yeah, thank you. And then there is the question, I missed the idea of the distributed power. Have you heard of that? Distributed power in future concepts. Why is it not followed up? Distributed power. Well, it's still looked at. And there are also different projects that are up and running. NASA has the X-57, for example, with the distributed electrical motors at the front edge, which is good for small aircrafts. But mostly they come with disadvantages. They have two electrical drives, but I still generate the same airflow that has to be moved somehow. And it makes sense if I need an aircraft that has small wings and good starting conditions for special purposes, like for larger traffic aircraft. You see that once in a while, but we have never seen so far that this really generates a benefit for everyday use, only for special purposes. Okay, thank you. And then there is another question about the propeller. Fly slower with the propeller and not too much loss, in order not to have too much loss because of the exhaust flow. Maybe it should mean how much slower do you have to fly not to have too much loss in the exhaust flow. Maybe that could be counter-rotating. That's maybe meant. Maybe the one who asked that question can repeat that orally here in that room. Then we know more precisely what it's about, if it was someone here in the room. So we know what is meant. Okay, no. All right. So are there questions here in the room? Otherwise, I would like to repeat the question that we will deal with tomorrow. What's your estimate and how it looked in the past and how it will be in the future? What do we have to do? Making sure that noise abatement is also considered in the future. How would you see that interplay? Who would like to start? And for you, Mr. Moal, I have a specific question on noise later on. Maybe from my point of view, from my estimate, noise abatement is clearly laid down in the regulations. And as you have shown this picture, this is given also today in the regulations. There are stricter regulations, and it has been understood by the regulators and incorporated. for climate protection, we don't have it the same way. So that was rather a development for cost reasons, or driven for cost reasons. Less fuel consumption developed because everyone tried to optimize costs, and the highest cost factor is fuel for airlines. And that developed further. And now we come to a point slowly and gradually where with the emissions we need to introduce rules and regulations somehow similar to noise abatement. Because here also we have a point where maybe flying becomes more expensive, and these measures don't come by themselves, but there are regulations for CO2 reductions, yes, but it's often self-obligation. And we have also heard that subsidies and grants for noise abatement have gone down, or research on noise. I don't have the latest overview here, but the classical funds from the aviation research program rather went in the direction of emission reduction lately. What would the others say? What would you say about that field at the moment for today and the future?
I do recognize there is a buzz around decarbonization at the moment, and Airbus was in there too. And yes, we understood drastically that the future of aviation was at stake. So the future of our company and all what we know today was at stake because, yes, we are burning too much CO2 and having other impact on the climate. So, okay, this is number one environmental stake for aviation, understood, but still, don't forget what's happening next. Don't forget the fallback effect on other parameters. So it's noise. Maybe not only. We can think about local air quality that may also come to as a parameter. It's very important indeed that it's not because we decarbonize that we forget about all the rest. Honestly, Airbus had this tendency at the very beginning, and now it's understood. Now it's understood that it's not because we decarbonize that we need to forget about the rest. We should not work on decarbonization technology with, I don't know how you call it in English, but like the horse. And it's understood in Airbus, we have now all what we need to work on the noise. Yes, we have more constraints because we have one more parameter to deal with, but it has been well understood. I hope it will be the case everywhere. I think the organization of this conference is also something which is showing that you are worried about this situation, and I do hope that this message could be passed to, yes, fundings body as an example, to be sure that they are not forgetting the rest of the environmental stakes.
Vielen Dank.
Thank you.
We've had a number of years where we've been really concentrating on carbon emissions. When you look at the government funding and things of that, it's been really kind of headed towards what are we going to do about carbon. And this comes after, at least in the United States, we had a number of NASA programs that were working called the Quiet Aircraft Technology and the Advanced Subsonic Technology that were really looking at noise. I think in Europe you had a number of big framework types of projects that were geared towards noise. And over the last few years, those have slowed down as some of that money got turned on towards carbon. But I do think, we are seeing with things like this conference, things like I mentioned, that Schiphol Airport reduced the number of flights in and out of it by about 10%, which they claimed was for noise reasons. The World Health Organization report, the FAA's report on neighborhood survey. We're seeing more of these things in the last 3 or 4 years that's starting to say, hey, again, we didn't forget about noise, but hey, it's still important. It's still one of those things. You got to continue to work on it. And so, technology funding always kind of drifts and has a pendulum swing to it that goes, sometimes it's this way and sometimes it's that way. I think we may be seeing that swing start to come back. You heard Stefan talk about having a lot of money to do work on noise. We're seeing funding to do work on noise with the continuous low energy and emissions program in the FAA. So, things are changing, and we are continuing to keep noise in our eyesight, or in our ears, maybe is a better way to do it, to keep making sure we're making progress on it and trying to head down the right road.
Okay, danke schön.
Thank you. I can only support what the colleagues have just said. The external pressure to reduce noise further is here. And with respect to funding and sponsors, well, hopefully it's just a pendulum, and then it will come back once this aspect is more focused on. It's understood that new technologies need to be developed and supported further before you can see how you can optimize them for noise abatement. Okay, thank you. We have one more question from before. You said that you are the noise expert, and Dr. Birch talked to me before. He said he wanted to know, at the end of the day, it's always about noise being a nuisance for people close to an airport. And if you built or designed an aircraft differently, if not only certification points were regarded, did I understand you in the right way? Would it be different if you really saw how noise is perceived and not only measured?
I think so. It can really happen, in fact. Could I find an example like this? Well, the fact that we are tackling first, and I think we have seen that also on Lufthansa presentation, we are tackling first the tonal components, the small line that we could see on the time frequency representation. It's designed for annoyance, because it is more annoying than a broadband. So yes, we are tackling first what is the most annoying. Then maybe later we'll try to reduce the broadband for the overall exposition to noise. But it's already a part of the work to target the nuisance. And typically we're talking about the open fan. So first we need how noisy it is. That's the first step. But definitely know how people are perceiving the noise between all the BPF 1, 2, 3. Can we play around with that so that we can do some kind of a design for to make it sound nicer? Personally, I have a dream about that. I would like. They are doing that in the car industry. They are doing sound design, improving the quality of the vehicle by sound design. You know, the slam of the door and the noise of the engine and so on. In Airbus, for the moment, we are more in the reactive mode, trying to understand what annoys people, but I would like to take the next step and to say, okay, how do you want our next aircraft to sound like? It's a long objective, I would think. Yeah.
Vielen Dank. Also ich glaube, das ist
Thank you. I think this is a subject which obviously plays an important role in this round. I saw another request for the floor. You get the microphone directly. Blomeyer Airport, Munich. I would like to make one comment. I think it's a great conference and we learn a lot of things where we as airports, and there are few representatives left and right, air noise is an important subject, and this is always where we get complaints and we have to deal with those complaints. So it's a great conference with a lot of findings. But one remark on the question of the hub function. Clear, point-to-point traffic has increased, but a hub like Munich or Frankfurt do have their advantages. It's not only the size, it's also the number of flights that play a role also for noise, and you need to say that. There is one other point that I would like to be interested in, but I'm not so sure whether this is the right group of recipients. It's about active noise, and in addition to the technology and the aircraft, of course, the use of this aircraft has to play a role. Mr. Hopp told us a lot in that respect. What can the pilots do? Making sure that there is less noise. We have our measurement locations like other airports, and we have observed that with the same types of aircrafts, there are different noise emissions. We see that. And we also see that there are different airlines with different loudiness at the measurement locations that we have, and we assume that there is a certain influence of pilots. Other airports like Heathrow, for example, they have a noise league where it is really registered who created more noise and less noise, and that's part of active noise abatement. My question, what possibilities do we have for the users of aircrafts, not the passengers like me, but for the pilots rather? Do they have possibilities to fly less noisy? Thank you.
So this is an Elna question, and tomorrow we will hear more about that. But Mr. Hepp, feel free to give us an explanation. Because you are recording, for example, how the individual pilots fly. Maybe you can say a few more words about it. Yes, of course I can. And I can invite you to take a closer look. If you find, for example, specific phenomena, I can establish a contact to Mr. Reiner, who is unfortunately not here, but he is a pilot himself. He is now graduating in a study and a very competent expert. And he is capable of analyzing the measurements which are being made in the cockpit. For example, starting with the takeoff run at the runway at the end or at the beginning of the runway. And what about the intersection activities? Is it departing earlier and steeper or less steep? So we take a lot of information and compare it then to the noise scenario we have. So we're doing that, and of course we can assist you. And secondly, what can the pilot do? If the pilot is approaching an airport, then together with the air traffic control, the existing measures can be used to fly, to approach in a noise optimized manner. One option is, for example, continuous descent. In Munich we had the CDO's continuous descent operations. And that's how we try to make this continuous descent procedure possible. However, it's also a challenge for air traffic control because they have to realign the other planes. They have to make sure that it's not too many planes approaching the runway. You have to make sure that they're queuing up properly, and if one plane wants to do that continuous descent approach, the track miles have to be calculated for flying laterally. And then I will start as late as possible with descending to have good synergy effects, which means CO2 reduction and noise reduction at the same time. But if we know that there is another plane approaching and that plane has to fly a few loops and is reaching too early, it might lead to another problem. And this is causing additional noise. So optimizing all that is really complex. And here you have to analyze the traffic peaks. On an airport, there are times during the day where lots of planes are approaching or departing. And if you have a deep peak, for example, you might have more options to reduce noise and CO2. It will be much easier. But here again, we are very committed. We would like to give you assistance. A cooperation between Frankfurt and Munich Airport is something we definitely look forward to. There's also a regional forum in Munich. I know that they are doing research in this respect, and when it comes to the departure procedures, we're checking out the cutback. The thrust is being reduced in Frankfurt, then we have the intersection takeoff, then we have the noise abatement departure procedures, which are being tested and analyzed, which means that takeoff thrust reduction is being tested, when to do it, at which height, and when do you accelerate. I mean, these are very specific information, but this is what pilots can do. They can influence the procedures they were given to by the airlines. So there is a certain bandwidth, but of course it has to match the air traffic control regulations. So it is something like a cooperation between the pilots, air traffic control, and the airline regulations, which means there are certain regulations which are compulsory to make sure that everything is safe, efficient, and quick. And this is, of course, reducing then the scope to maneuver for the pilots, which does not mean that we cannot improve. But the more people are involved, the more people have good ideas, the better progress we will see. Thank you so much. You have not only given us an answer, but you have also made an offer to the Munich colleague to give real support. Any other questions? There is no question from Slido, but I can see one question over there. Thank you. My name is Bart, and I would like to go back to what Mr. Blomeyer said. And the question is for Airbus and Boeing. What about the pilot? You just talked about a new design and the relationship between the pilot and the plane, and how can I fly it at the lowest possible noise. And of course air traffic control needs to be involved. But what kind of assistance systems, what kind of information can be given to the pilot beforehand to make sure that he or she is flying as quietly as possible? Or are you only taking care of the hardware? And then the human-machine interface is something which needs to be organized by the airline alone.
The manufacturer team is working very actively on those topics, definitely. It was said during Mr. Hoff's presentation, the burden on the pilot to approach is something heavy, or takeoff also. So we have to be sure that we are not introducing more burden in his work because of noise concern. So yes, typically discussing with the pilot what are his needs, and so that the avionics are helping him to guide him to the right time to release the landing gear and so on. This is something which is important. It's something which can be local, and we can have not the same thing between different airports, which introduce some more complexity. And that's typically when the learning that we get when we go towards the airport communities. We learn some specificities of each airport, and we come back to Airbus and we say, look, in Munich they're doing that, in Frankfurt they're doing that, in Charles de Gaulle they're doing that. And learning with all that, we can improve also our avionics system to help the pilot in this complex phase to be sure that he does the right thing at the right time without too much burden. And on top, I would say that nobody knows better our aircraft than ourselves, and especially on the noise, it can be complex to know what is the best procedure, because you say like in takeoff, I will go full speed so that I will climb higher sooner, so I won't disturb people. Yes, but the people which are close to the airport will be more annoyed. So what are the choices that you make, how you use the procedure? We have all the tools to calculate all that. We are doing it very regularly, and this fine optimization, we will be happy to be in the loop of all this discussion to help you in this process.
Yeah, I would say we're doing very much the same types of things. There is a ton of work that goes into working with the pilots to understand their workload, and that you're not overburdening them with other types of information that's not helping them be safe, which is the number one thing that you want to look at. But we are working on those things. What are some ways that we can kind of highlight when we think they're going to be running into a low noise configuration and do the best? But it is a concern, because sometimes you might be doing a low noise for one neighborhood and it may be increasing noise in another neighborhood. So is that the right answer? And so we've got to work through all of those types of things, working with the pilots to try and figure out what is that right balance on everything.
Okay, vielen Dank.
Thank you so much. What about other questions? I see that some have already left. It's 6 p.m. The agenda says the conference ends at 6:30, but we don't have to stay here until the very end. I mean, we have worked hard and we can call it a day right now, but you have to be sure that you have no further question and that we've really answered all your questions.